Welcome to the deep dive. Today we're going to tackle something really useful in Java, deferred execution.
Yeah, it's a powerful concept.
So imagine you're planning something complex, right? You don't do every single step right away.
Exactly. You often decide when to do certain steps later on, maybe repeat them, or only do them if needed.
And in Java, a key way to handle this kind of delayed action is using Lambda expressions.
That's right. Lambdas let you bundle up a bit of code, like a task, and pass it around.
So you can decide later when that code actually gets executed. Let's dive into how that works.
Sounds good. The basic idea is packaging behavior. Instead of running code immediately, you wrap it in a Lambda.
And hand it off?
You hand it off, yeah.
Right.
Some other piece of code receives this Lambda package and decides, okay, now I'll run it. Or maybe I'll run it multiple times.
Okay, let's make that real. Say I want to print hello world 10 times. How would a Lambda help there?
Well, you could have a method, maybe call it repeat. It takes the number of times, say 10, and the action.
And the action is the Lambda.
Exactly. You'd write something like repeat, parenthesis 10, comma, then the Lambda. Open parenthesis, close parenthesis, arrow, system.out.println. Hello, world.
Okay, that parentheses arrow bit is the Lambda doing the printing. So what's happening inside that repeat method?
Good question. That Lambda, the parentheses arrow system.out.println part, it matches a functional interface. Probably runnable here.
Ah, runnable with its run method.
Precisely. Runnable has one method, run, that takes no arguments and returns nothing. Our Lambda fits that perfectly.
So the repeat method takes an in-n and a runnable.
Yep. The method signature might be public static void repeat, in-n runnable action. Inside, you'd likely have a simple for loop.
Like for int I equals 0i and I++?
Exactly. And inside the loop, you call action.run.
Ah, okay. So the Lambda's code, the system.out.println, only runs when action.run is called inside that loop 10 times in this case.
That's the deferred execution right there.
Yeah.
You define the what, print hello world in the Lambda, and the repeat method decided the when and how many times.
Makes sense. Is this pattern used in the standard Java libraries too?
Oh, absolutely. A good example is Arrays.setAll.
Okay, how does that work?
Imagine you have an integer array, maybe size 10, and you want each element to be its index squared. So element 0 is 0, element 1 is 1, element 2 is 4, and so on.
Right.
You could write var squares equals new and 10, then arrays.setAll squares, index, index, index.
So that Lambda is index, arrow, index, index.
Yep. It takes an integer, the index, and returns its square. It matches the in-function interface that settle expects.
And again, the squaring doesn't happen all at once up front.
No, that's the key. Arrays.setAll iterates through the squares array. For each index, it calls your Lambda, passing the current index in.
And uses the returned value, the square, to set the array element at that index.
Exactly. The calculation index is deferred until it's needed for each specific element during the iteration.
That's quite elegant. Now, back to our repeat example. What if the action needed to know which iteration it was on, like for a countdown?
Ah, good point. Runnable doesn't take arguments. But there are other functional interfaces, like in consumer.
In consumer, that sounds like it consumes an integer.
It does. It has a single method, except, which takes an int argument and returns void. Perfect if your action needs an integer input.
So you could rewrite repeat to use in consumer.
You could. The signature would change to public static void repeat into an in consumer action and inside the loop.
Instead of action.run, you'd call action.acceptI, passing the loop counter I.
Precisely. You pass the current iteration number I to the Lambda via the accept method.
And how would you call that version of repeat?
You'd write the Lambda to accept that integer, something like repeat 10 i-system.out.println countdown plus I.
Okay, so the Lambda is I, arrow, then the print statement using I.
Right. The Lambda now declares the parameter I, and it receives the value from the repeat method's call to accept. The printing is still deferred, but now it's parameterized by the loop index.
So the real power here is defining a block of code, the Lambda, and letting some other method decide when, how often, and maybe even with what data it gets executed.
That's the essence of it. It gives you tremendous flexibility. You separate the what from the when and how.
Yeah, I can see how that leads to cleaner, more reusable code. You define the action once and pass it wherever it's needed.
Absolutely. It's a cornerstone of functional programming styles, even within Java. Very useful tool.
And definitely something to have a good handle on, especially, for folks prepping for Java interviews, particularly at a more senior level.
For sure. Being able to not just use Lambdas, but explain why you're using them for things like deferred execution, that shows a deeper understanding.
It signals you can think about structuring code in flexible ways.
Exactly.
Great stuff. Thanks for breaking that down.
My pleasure.
All right, that's all for this deep dive. Join us next time.